Now we're going to do the last two problems. In this problem, number 18, you're pulling your 18-kilogram suitcase at a constant speed by pulling on the handle. That handle makes some kind of an angle with the horizontal. We're not sure what that is. We know the friction force on the suitcase is given in the problem as 27. We know that we're pulling, so this force that goes along here is 43 newtons. And we're trying to figure out, well, what is this angle? How do we do that? How do we find that? Well, here's how we do it. If we can figure out these sides, or at least one of these sides, we would be able to figure out the angle because we would know the hypotenuse, because that's given at 43. And if we can find one of these other two sides, we'll be able to figure out what the angle is using a little geometry. So I'm going to take a look at the left and right. The reason I'm going to take a look at left and right, not up and down, is I've been given force of friction, which is a force in the left and right. That's 27. So that's what I'm going to do. So if I'm adding up my left and right forces, I know the force of pull in the x direction. That goes directly to the right, so it's positive. Minus the force of friction, because that goes to the left, equals 0. So my right stuff, force of pull in the x, equals my left stuff, force of friction. Okay, well, what is force of pull in the x? Force of pull in the x is the adjacent side of this triangle. So I'm going to use cosine. Cosine of my angle times force of pull, which was given at 43. That's going to equal force of friction. So now I'm just going to divide my force of push or pull to the other side. So that's why it's in the denominator over here now on the right. So friction over force of pull equals my cosine of the angle. But I don't want the cosine of the angle. I want the angle itself. So how do I get rid of a cosine? You do the inverse cosine. You can't divide a cosine. You can't multiply. You do the inverse. So that's why this cosine minus 1 of friction and force of pull divided by each other. So theta equals the inverse cosine of force of friction, which is given at 27, or the force of pull, which is given at 43 newtons. And when I plug that into my calculator, I get 51.1 degrees. Finishing it up with number 19. We've got a 1,500 kilogram car that's parked on the road. It's got an angle of 10 degrees on the hill. We're going to find the normal force, and we're going to find the force of friction acting on this car. Going left and right, my force to the right in this problem is the force of friction. My force to the left is the force of gravity parallel. So my right stuff equals my left stuff. My equation for gravity parallel is the sine of the angle, which is 10 degrees times mg. I'm going to plug in my mass of 1,500 kilograms, my g of 9.8 meters per second squared, plug all this into my calculator, and I get 2,552.6 newtons for friction. Up and down, my upward force, normal force, minus my downward force of gravity perpendicular equals 0. So normal equals gravity perpendicular. Gravity perpendicular is the cosine of 10 degrees times mg. That's one of the equations on your equation sheet. Plug in 1,500 kilograms for mass, 9.8 meters per second squared for g, and I get that the normal force is 14,476.7 newtons, and that's it, the end.